Alright, hi year 11s, this is Mr. Lim here again, and this is our 8th video on covalent bonding, or chemical bonding, and on covalent molecular formula. So let's get started. Okay, so we've got, this is what we're going to learn, and we're going to learn about condensed structural formula and molecular formula and naming stuff. Alright, so let's get started. So as we saw before in the last video, covalent molecular substances are comprised of small groups of atoms covalently bonded together in groups called molecules. And so the components members of those molecules, the atoms that make up those molecules, can be shown in a number of ways, but the molecular formula and condensed structural formula are the most common. All right, so the molecular formula shows the number of each type of atom and how many there are in each molecule. Oh, that's actually saying the same thing, doesn't matter. Right, and then the condensed structural formula shows the number of each type of atom, but often arranges the letters of the formula to show how the atoms are bonded to each other, right? And this is common for hydrocarbons and organic molecules where the same molecular formula can have different structures. Okay, so let's have a look at an example. So for example, I have C2H4O2, right? There's a number of ways that C2H4O2 can bond together. For example, you have this one here where you have CH3 COOH. Okay, so this is the condensed structural formula, the CH3 COOH. And what you have here is you're showing that the first carbon is bonded to 3 hydrogens, and then the next carbon is bonded to the oxygen, the other oxygen, and the hydrogen. Okay, so it's showing the structure of the thing. All right, the next one here shows that you have a H, then an O. Okay, then you have a CH, then you have the other CH, and an OH. Okay, so you even notice that one's written backwards, the OH, to match the structure that it actually forms. But what you'll notice is that both of these structures are C2H4O2. Okay, they have the exact same molecular formula, right? Which is why we often use the condensed structural formula to show certain ideas, because it's a lot more useful than the molecular formula. All right, but the molecular formula does have its uses at times. So how do we name covalent molecular substances? So here's the idea. They're based on the number of atoms of each element in the substance, okay? Or by the presence of certain structures of the element which change their chemical properties, which are called functional groups. We're not going to get into functional groups later on. So we name stuff by functional groups in organics, and so we'll do that when we get to the organics topics. But for basic inorganic molecules, which is not carbon and hydrogen based, right, generally elements towards the left and the top of the periodic table are listed first. All right, the number of atoms of the first element is shown by adding prefixes to the elemental name, unless there is only one. All right, in which case no prefix is added. Then the number of atoms in the second element is shown by adding prefixes to its elemental's name, even if there is only one. So the end of the name is also changed to "-ide" in many cases of single atoms joining to each other. All right, so if there are more than 3 elements, it's likely to be organic substances which are named with different rules, which we'll go through later on. But here are some examples about how to name some stuff. Okay, so here we have a phosphorus and 3 chlorines. Okay, so we will say, okay, well then the one towards the top left was named first, the P, all right, or at least towards the left. So this is a that's not what I wanted. This is a phosphorus of some sort. Now remember, because there's only one of them, it doesn't actually matter that we're saying phosphorus. We don't have to say monophosphorus, because there's only one of them and it's the first atom. All right, but then we have 3 chlorines. So we don't just say phosphorus chloride, we say phosphorus trichloride. All right, and the idea is that we change the chlorine to chloride because it's part of a molecule, no longer by itself. Right, here we have another one, 2 nitrogens and 4 oxygens. So now I do need to give a prefix, so it's now dinitrogen. Okay, so you notice the nitrogen didn't get a change to the suffix, so it's nitrogen, not nitride. All right, just like phosphorus wasn't phosphide. And then it's tetra because it's 4 oxide. dinitrogen tetraoxide. Okay, then we have carbon monoxide. Okay, so mon, so you don't have to do mono, but mon can be for enough if there's starting with an O, right? Monoxide. But if it was something like fluorine, it might be monofluoride. Okay. Here we have water, which has a common name, which is most commonly used, but it can also be named scientifically. So it's called dihydrogen, and then monoxide, because one oxygen, dihydrogen monoxide. And then we have another one, nitrogen trihydride. Okay, so now I know that the hydrogen is on the top and the left, but for some reason they put it on the bottom, on the back end here, so we just follow that structure. This is nitrogen trihydride, which also has a common name of ammonia, and we'll be dealing with lots of stuff with ammonia later on when we get to acids and bases. Okay, but they do sometimes have common names, which you will have to know a few of, but you can also name them by their proper scientific names as well. All right, so that's it. Adios.